Dr. Metzler here. Today we're going to be doing a lab called Observing Ionic Reactions. The paper looks like this. You can see that before you start watching this video, you're going to need to look at the table, think about very carefully what this is talking about, and then you're going to need to write two different hypotheses. So I want you to stop this video now, and I want you to go ahead and do all of those things before you go on and watch the lab itself. Okay, so now that you've written your hypotheses, we're going to do the first part of the experiment. What I'm going to do here is I've got a petri dish and it's got some water in it, and I have some potassium carbonate and I have some copper chloride. And we're going to see if when we put these two things close to each other and we dissolve them, if we're going to get some new compounds made. So I'm going to go ahead and put some of this potassium carbonate over here, and I'm going to put some copper chloride over here. And we're just going to need to wait for a few minutes to see what happens here. And we're going to watch it. What's happening now is that the two salts are dissolving. So I'm going to just tell you a few things while we're watching this. First of all, I want to remind you that salt just means an ionic solid. So some kind of solid that's made of ions. You've got a cation and an anion together. All right, what we're seeing here is you're seeing that things are dissolving, starting to spread out. You kind of notice a color change here with the green copper compound as it's dissolving in the water. Okay, and that's just something that copper does when it hits the water. The potassium carbonate, you really can't see that much is happening, but we're going to be patient and we're going to see what's happening, what's going to be formed that's going to be a new compound. Now, while you're waiting, you can go and look at your table and see which of these compounds are, actually, I think the camera should continue just watching this because it's about to start happening here. And I'm just going to talk while this is starting to happen. And I'm going to say that you can go and look at your table on the first page about what is soluble and what is insoluble. Soluble compounds, those dissolve in water. And you'll see that the copper chloride and the potassium carbonate both dissolve in water. But if you look at possible products that could be produced when you mix these two compounds together, you'll see that one of them is insoluble. That means it doesn't dissolve. So if you think about what you're seeing here, you're starting to see something that's kind of like a powder forming at the edge where the two compounds are meeting. They've dissolved, and now they're starting to form this thing, this kind of edge that looks cloudy. And that's what you're seeing in the video, and that's what we're also seeing live. It really does look like that. It looks cloudy. So I'm going to leave this one. We'll come back to it and see if it changes any further. Oh, I'm just going to point out to you that you'll want to make a drawing on the third page of your paper. Okay, you're going to want to make a drawing using colored pencils, which will be out at the back of the room, and also you can make written observations. You're going to explain what you see. Now let's move over to the second experiment, which is the next dish over. And what I'm going to do here is, once again, following that diagram that we have, and I'm just going to show the diagram for a minute just to remind people. That's what it looks like. The sodium hydroxide goes at the top, the copper chloride, that's the green one, on the left, and the calcium chloride on the right. I'm going to do my best to put them down here in the dish as close in time as possible, in other words, as rapidly as possible. There's the copper, and here's the calcium, and then our sodium hydroxide pellets. This is the one that's hazardous that I didn't want you guys to handle. Now, we're just going to watch and see what happens. Once again, you see the calcium and copper salts dissolving, especially the copper. You can see it's dissolving and starting to spread. So let's look at what's going to happen the sodium hydroxide is also dissolving along with the calcium chloride. So what you're going to try and figure out is what new compounds are forming here. So we're going to have to think about that. Think about the colors that you're seeing, because you see a line forming, but is it the same color all along? Copper salts tend to be blue or green, whereas most salts, especially salts of things like calcium and sodium, are going to be colorless or white. So you can see something slowly developing here. Now these, once again, you see this line is made of cloudy material. You have to think what that means. Why is it cloudy or powdery looking? And how is that different from the clear parts of the plate where you just have the dissolved soluble salts? Okay, well that's continuing to develop. I'm going to ask the videographer to come over and look at the previous one so you can see how this has developed and how much it's spread. All right, so you can really see the cloudy effect along this line here. And that's what I want you to draw, and I want you to describe it. You see it's still clear here, and this is green, but it's also clear. But this along here is cloudy, and what does that mean? Okay, so let's go back to the second one again and see what that's looking like. Now you can very clearly see. Look along here and you see that there's no cloudy line. Where these two are mixing here, the copper and the calcium salt, where they're mixing, there's no line formed. But along here, you see a line formed, and you see that there's two different colors to it. You need to think about all of this. Now what I want you to do is I want you to draw a picture and describe what you see there, and that's going to go, I'm just going to show the paper again. That goes over, that's Petri dish 1, and there's Petri dish 2 that's going to have the two different colored lines. So let's look at it just one more time, and then I think we can stop the video because that brings us to the end of the experiment.